Okay, good afternoon, everyone. So we have someone here from the tutoring service who would like to explain that for a couple of minutes, so I turn it over to you.
Hi, I'm Jeff from the College of Science Advising Center, and we offer free tutoring in math and science courses. And for the first time, we have a computer science major working with us. So he's going to be tutoring for this class. So you should definitely come in, take advantage of it. It's the first time we've had a computer science major with us, so we really should take advantage. We're over in Duncan Hall 213. I'll leave these flyers up here that have our phone number and email because that's the best way to contact us to make an appointment. So is there any questions from anyone? Okay, so I'll just leave these up here. You guys can get them after class.
And if you can email me that information, I can put it up the course website.
Okay, I'll send you a
Yeah,
flyer.
for those people who no longer keep flyers. All right. Yeah, so it appears there's more than one tutoring service. So we're supposedly having one in the department as well, and they're supposedly getting started real soon now. But this would be another option. So give it a try and see what happens. So if you're stuck with the homework, by all means bring it to the tutor. Let the tutor give you some hints. Make sure the tutor doesn't solve your homework. You're not learning anything from that. And let me know if you have any feedback, good or bad, about how this particular service works out so that I know whether to recommend it. Before I get going, are there any questions? No questions? All right. Can I just have a show of hands who has trouble connecting to the internet? Well, that's a significant number. All right, let me call. All right, let's see if that helps. Any other questions? Yes? All right, so let's see. Okay. Homework. This is homework 3, right? Part C. All right, so I'm just looking at the tester here. And so I now need to submit some work where this stuff compiles. So I need to have a move method. I need to have a turn method. I need to have a getX and a getY method. And they both need to return 0 in the draft. So I need to just put in my stubs here. So if I start up BlueJ real quick here. New project, homework 3C. New class. What is it? Bug2. Okay. Well, this time I guess it wasn't particularly generous what they gave us. So now what are we supposed to have? We're supposed to have a constructor. And it doesn't do anything yet. Supposed to have a move method. And it doesn't do anything. We're supposed to have a churn method. Doesn't do anything. We're supposed to have a getX and a getY method. And I guess they return integers. Okay, here we go. Paste it in. Looks good. I think I'm done. So, so when you do these stubs, the idea is that you write down what this class can do, what an object of this class can do, and so it's easy enough to write up all of its methods. We're not yet worried how those methods are implemented, how the objects can do any of these things. We just want to get the basic contract right, that these are the things that can be done. Why do we bother to put in return 0 in here? I'll just show you what happens if you don't, if you just leave this one empty. And if you compile, then you get an error message here that says missing return statement. So it doesn't compile. So that's, in order to get it to compile, I have to return something. And so we'll just return 0. Doesn't. That's the simplest thing to return. And so now we have a class that compiles. What's missing? Nope. Otherwise, it wouldn't have compiled. What's missing is the comments that explain what this thing does. So we're going to be covering that in the lecture pretty soon. So what you really want to do a good job in this is you want to write what it does. Gets the X position. To return. We'll go into the details of this soon. A little bit boring to write. Not everything in life can be interesting. So NetBrat doesn't know about the comments, but still it is considered the right thing to put them in. All right, so that now completely finishes the draft of 2C. Other questions? Yes?
Do we lose points if we didn't put comments?
At some point you will. So at some unannounced point, the grader will start paying attention to it, and I don't yet know when that is. So you have two strategies to deal with that. Strategy number one is to just always put them in, and you'll be good. Strategy number two is to not put them in until you lose a few points when the grader complains, and then afterwards put them in. So I leave it to you which of those two strategies you choose. Yes?
For the void statements example, we have, can we have arithmetic in the void statement, and will it store the value of it? Or?
Well, you can have arithmetic in it. So, for example, the way that move in all likelihood works is it's going to update some direction. And yeah, you can absolutely do that. Let me do the bug because it's simpler than the bug too. So let me close this here and make a new project. Oh, that's not so great. So So internally, you're going to have some instance variable that gives the position. And over here, you could certainly update the position by saying position equals position plus 1.
But whenever, like after the void statement,
Yeah?
will it go back to the initial value of position, or will it store its value?
It'll store the new one. Let me complete this. So let me have a, is it a get position? Yes. So here I have an accessor that gets it back. And let's just run it. So we make a new bug. Here's Fred, our new bug. So we're asking it, what's your position? Right now the position is 0. We're going to ask Fred to move. I'm going to ask it, what's your position now? And now the position is 1. So again, notice how nice BlueJ is, that if you start coding up your class and you just want to have a quick feel of how it behaves, simply right-click, make an object, give it a name. Here's Mary. And now you can call any of the methods. So I could call move 3 times. I can call get position, and I see now the position is 3. So I instantly have satisfaction that I've gotten my move method to do something sensible. So now I can go and say, what's next? I want the bug to turn. Don't you know how to do that? So I'll compile it. When you compile, unfortunately, your old objects go away, so you have to make new ones. So let me make a new one here. So here's Fred again. And now we'll make Fred move, and turn, and move, and ask its position. And unfortunately, that didn't work, because what we wanted Fred to do was to do the following, that, Freddy was here. Come on. We wanted him to move, then we wanted him to turn so that now it points the other direction. So if I make Freddy as a little triangle here, we now wanted him to be like this, and then we wanted to move backwards like that. And that didn't work, and it couldn't really have worked if you look at the code here, because there's nothing in the code where it remembers the current direction. So Freddy has total amnesia. It remembers where it is, but it doesn't remember its direction. And so that can't work. So you have to come up with some strategy of endowing Freddy with that memory, and then you have to use that memory later. And I'll leave that up to you to ponder right now without wanting to give away the complete answer. Yes?
I was looking at your book on section 3.5 on the cash register example.
Uh-huh.
You have 2 instance variables, private double purchase and private double payment.
Yeah?
And then you also have declared a variable under the give change.
All right.
How come you did? How do we know if we should declare it under there or instance variable?
I see. Now that's an excellent question, and I'll give a quick answer, and I'll come back to that later because it's a common misconception. So let me pull up that particular code, and I'll just do it in a text editor in the interest of speed, because I don't have a BlueJ project for it yet. Alt X. Code. Chapter 4. Was it chapter 3? Chapter 3, right? Cash register. All right, so here we have the code for the cash register, and you were looking at like this particular method here.
Give change.
A give change, fair enough. So here, and so his question was, over here we have a variable double change, and up here we also have variables for the purchase and the payment. And so the golden rule is that if you want an object to remember something for longer than one method call, you need to put it in the instance variables. If the object only needs to remember it for a single method call, then it's better not to overburden its poor memory and to use a local variable. So that's the rule, and I'll come back to that because it is an important point. And so we're racing way ahead of the lectures here. Other questions? You had a question? No. So I realize that that homework 3A is pretty trivial. All you have to do is put in those stubs. And so go ahead and do that. Submit your homework. You know, you can do it tonight. I mean, it shouldn't take longer than a few minutes to do it, really. And then keep working at it. Because, of course, there's a long road from the stubs to the actual assignment. Particularly to, I think, 3C, the 2D bug is a little bit tricky. I mean, it's not rocket science, it's just bug science, but it'll take you longer than a few minutes. So, all right, moving along. So we're slowly catching up with the homework. It's that Labor Day that's done us in. Accessor and mutator methods. So when you call a method that makes no change to an object, that's called an accessor method. So here, if you have a rectangle, getWidth is an accessor method. Or over here with my bug, getPosition is an accessor method. Let me go back to my bug. So I can call getPosition as often as I like, and as long as I didn't call any other method in between, I always get the same answer. So that's the hallmark of an accessor method. You can call it as often as you like, you get the same answer back. It just tells you something about what goes on inside that object. And it's really our way of observing objects. You observe objects through querying those accessor methods. A mutator is the exact opposite. A mutator does not normally return a value. Some mutators do for convenience, but in general, a mutator returns void. And it changes the state of the object in some way. So over here with my bug, move is a mutator. I call move, and now the bug is somewhere different. Of course, I don't see it to be anywhere different because it's just this blob that's modeling this. What really is just a bunch of numbers. But the state has now changed. Every time that I call move, and afterwards I call an accessor, I can see the change in state. So it's an important technology. Mutator makes a change. Accessor doesn't make a change, but reports something. All right. Yes, this is actually a good question. So let's try to do this. Let's hope a good number of people are now on the internet.
So Brighter is
All right, so to give people another chance to get on the internet, let me tackle that question. So his question was, is Brighter for color, is that an accessor or is it a mutator? And that really is a great question. So let me write this up. So if I have a color C, and it is whatever, a new color, pick some values. And now I call C.Brighter. So the question is that an accessor or is it a mutator? Does it change C? No, it doesn't change C, right? It returns a brand new brighter color that I actually have to capture. And so since it doesn't change C, it's an accessor. Now you might say it doesn't actually tell you a particular property about C. It returns a new value, but still, we'll say it's an accessor because it fails to mutate C. All right. Go to Piazza and post.
only in this class do I have trouble logging in.
Yeah. Um, wait, so does the Premiere thing again not work? Premiere is down?
I'm having trouble logging on.
Okay, so all right, so yeah. Yeah, I'll kick. Yeah, I'll look in a minute, but for those people who can get on, let me post this. Hi, this is Kyle. I'm teaching at Washington Square Hall 109. We again have some performance that's probably this start by all right. See how we're doing. All right, so let's just talk about it and see what happens with our network issues here. So we have these three methods here: string.toUppercase, and that clearly is not a mutator because when I call, say I have string name equals Fred, and now I call name dot toUppercase, then afterwards name is unchanged. It returns an answer, but it doesn't change the name. Well, we did this last time in BlueJ, but let me, since it's a cheap thrill, let me do it one more time. So string name equals Fred, name toUppercase, returns Fred in uppercase, and then when I query name, then it's still with the characters in lowercase. Not a mutator. All right, let's look at the next one here. Rectangle.grow. We had that one in the previous homework, and it did actually change the rectangle. Let me just demonstrate that real quick. So if I have rectangle R equals new rectangle 5, 10, 20, 30, and now say r.grow 100, 100, say, or 110, doesn't matter. Oops, yeah. And then I ask what's r. Oh, then it says me some object reference. So let me say r.toString that I can see it, and it's different. It goes now minus 95, and there's 220 here. So it got mutated. I called grow, and it mutated. And now the third one here, printstream.println. So if I call printstream, that would be system.out. That's in. So if I call system.out.println, hello, semicolon. Okay, did I just mutate system.out? Well, let's actually find out by looking at it. So, okay, whatever. Here's system.out, and we can inspect it. And so it has a bunch of stuff in it here. So it has a complex set of structures, so one would even have to look inside this one here. And so when I now invoke a method on it, like print on that I did from over here, system.out, sorry. So the question is, does it change? Does it modify this particular object? And first of all, you can't say obviously not, because you have no idea what goes inside the object. Right? It's a big opaque thing. And then if you think about it, chances are that it probably does make some change inside the object. Because what does system.out do? It somehow interacts with the terminal. Certainly the terminal has changed. Before it was blank, and afterward it said hello. And afterwards, when it did it twice, it said hello, and then it said world. So the terminal has changed, and so it's extremely likely that in order to effect that change in the terminal, that also something changed in system.out. And in fact, that is true. System.out does certain things, like it keeps track of how many characters it has already printed. That count is going to change when you print more characters. So system.out is actually mutated by calling print on it, and so the correct answer would be 3. See if we had any of those. And so 6 people did say that. So, all right. So system.out is an object. It's a big fat object. It has a lot of responsibility. It's not an easy thing to make characters appear on a console window, and the bookkeeping that it uses is mutated when you do things like print onto it. I'm not even sure whether PrintStream has any accessors. We could find out. So let's see if there are any methods that return. There is check error. See, all these others return void. So we could just try to see what happens when we call check error on it. So out check error says false. That means there was no error so far, which is not surprising. So as a general thing, when you look again at print on, notice that it returns void. That gives you an indication that it can't be an accessor. An accessor must return something. And it's got to do something, right? Otherwise, there would be no point in calling it. So it must affect some change, and so that would be a powerful indicator that it's a mutator. So a method that returns void, unless you purposefully make it do nothing, is bound to do some mutation on its object. All right, that's why I said it's a good question. All right, API documentation. We've seen this a million times. That I keep pulling this up. It's this documentation that lists on the left the various classes. So I can look up, for example, for rectangle. And then when I click on it, then you see the various methods that the rectangle class has to offer, constructors, methods, and then you click on one of them and say intersection is a familiar one. Then it explains what that method receives as parameters. That's here, and what it returns for its results. So I don't think I have to go through there again. Packages, you've already seen that in the previous homework. It's a package is a way of organizing the various classes in the library. And so why is there a need to organize them? Well, if you look at all of the classes that Java has to offer, classes. There are, at last count, 4,027 classes in the Java library. I just pasted them in here and looked at the line number. And so you can see that if you have 4,027 classes, then that's a lot of classes, and you need to have some way of organizing them. Don't worry, you don't have to memorize any of these, and you don't have to be familiar with a large number of them. If you ask me how many of those classes I know intimately, oh, that's actually cheating. There's only 4,024. All right, I feel much better. So you don't actually have to be familiar with a very large number of them. A practicing programmer will know probably a few hundred of them by the time that they graduate from college and have put them to work. And I would say probably half of them I have never once looked at. So if you ask me, for example, what W-string seek holder does, I think I can confidently say I will never know in this life. But still, we do need to know a good number of them, and the API documentation helps us find them. So the packages, organize them. The packages are listed up here. You could narrow down searches to an individual package, and that's sometimes a useful thing to do. So I might, for example, want to know what are all of the things in Java AWT-GEOM, and then I could click on here. And then here I have a much more manageable collection of classes that have to deal with two-dimensional geometry. So you see familiar things like lines, ellipses, cubic curves, maybe not so familiar to you, but they will be once you've taken a graphics class. All right. So when you want to use something from a package, you typically put this import statement into your program, and then you can use the rectangle class by name. You don't strictly need to do this. If for some reason you dislike packages, you could just always write java.awt.rectangle. It's just that your code then would be more awkward. You would have to write, for example, java.awt.rectangle rect equals new java.awt.rectangle. That would be legal without a package declaration, but that's tedious and we don't want to do it. So the package takes away the tedium of referencing each of those by their full name. Now there's a few classes where you never need packages. Those are the ones in the Java lang package. So string and system are in there. Let's see what others we can find. So if over here we restrict ourselves to Java lang, then you see there is a handful of classes, not very many, and those all come for free without having to use any package specification. The only ones that we're going to be really using in this class are, we're going to soon be seeing integer, string, of course, system, and that's pretty much all that we're going to be needing here. All right. Do I want to do this? Let me not do this unless we have something, we have nothing more important. Testers. So this is a very important part, and as you're seeing in NetBrat, you see these testers all the time. So the idea is that when you design a program, at the same time you want to worry about how to test a program. So right now we're not yet designing, and in Chapter 2 we're not yet designing any classes, we're just using them, but even when using them, it's a good habit to do that. So let me just come up with a tester for something on the fly. Let's say I wanted to come up with a bug tester here. You don't have to do this for the homework because I'm actually giving you the tester, but I'm walking you through what you would do if you wanted to write a tester. Our testers will always have a main method. So just copy and paste this line from somewhere. And now I make myself an object of the class that I want to test. It's the bug here. I'm going to do something with it. I'm going to then print out some property of it. So I want to know, where is Fred after he's moved 3 times? And this program will print it out for me. When I run this program, what will it print? The gentleman at the front row says 3. So what he does is he expects it to print 3. And so let's record that fact. And this line here, the expected line here, is the most important part. And so in all of the testers that I will make you write, and I'll start making you write a few pretty soon, and definitely there'll be exam questions where you have to write testers. With all of those testers, what's really, really important is that you know what answer it should be. Because you can't check whether a program does the right thing if you don't know what that program should be doing. And more importantly, when one starts thinking about what should it actually be doing, that really calls to question, how is this whole thing working? And in many, many homework assignments, that's a key to get the homework done, that you have to be able to figure out by hand, in your head, or with a sheet of paper, depending on how complex it is, what is actually supposed to happen. Because if you don't really know what's supposed to happen, you have 0 chance of coding it. It sounds like an obvious observation, but you'll be surprised how many of your colleagues will nevertheless try. So it's really, really important that you first know what it is that's supposed to happen. And so when I write my own programs and I write these testers, invariably when I come to this point where I need to print out what is it expected to do, I have to pause a bit, because usually I don't quite know. I usually then get out a piece of paper, work out the example by hand, and then I say, oh, that's what it's supposed to do. So let's run this program. So I'm just running the tester. Note I run the tester, not the bug. And it says the actual value is 3, and it also is expected 3, and now I'm happy. Right? Instant happiness. That's what programming is all about, as we all know from those interminable homework sessions. So, but this is good, right? So something is actually working. And am I done? Is the bug now done? Well, the tester tells you that this particular test case has been happy, but it's possible that other things fail. So, for example, when Fred now turns around and moves, and it should be print on. I should just copy the whole thing. So now what do I expect? 2, right? Because it goes backwards by 1 after having turned around. So let's run it. So now you see that's not so good. Right? It's supposed to print 2, but it actually printed 4. And so that's not such a happy thought. But it's actually not so bad, because now you have a specific case where things aren't working out. You exactly know what the inputs are. You exactly know what it's actually doing versus what it's supposed to do. And with that knowledge, one can usually make some amount of progress. See, now you can ask yourself, why did it print 4? And now when you look at the source code for bug, then you say, well, every time that you move, it just stupidly adds 1 to the position. Well, that can't possibly be right? Because sometimes it's supposed to add 1, and sometimes it's supposed to add -1. How do you do that? Okay. so that would be a private.
And then the term changes.
Okay, well now let's try it. Oh dear, that was worse. Now it never moves anymore. Bad bug.
You have to instantiate the.
So I have to initialize this thing somewhere. Do I have a constructor? So in the beginning, I guess I want to add 1, right? Okay, now I'm back to this behavior, and this one is still not working. And so now I'm leaving it to you how you could change this value here so that it flips from 1 to -1 when you turn. And I'm also leaving it to you to come up with a better name than sometimes 1 and sometimes -1, right? Clearly there is a better way of naming this thing so that it really shows what it's doing. And I'll leave all of that to you. But when you do that, then you'll find that your program passes these 2 test cases. That doesn't necessarily mean that it's now correct, and so it would be prudent to throw another test case at it, maybe have it turn and turn again, and see that it again moves to the right. And after some time, there's diminishing return, and you would stop adding test cases and simply have it be done. All right, so the general recipe you've just seen. You supply a main method. Inside the main method, you construct 1 or more objects. We did that over here. Let me get the tester back up. So here's my object. This time I did 1. Sometimes you have more than 1. Depends on what you want to test. Next step, you apply methods. And I think it's fair to say you apply a bunch of mutator methods to the object to kick it somehow, to make it do something. And then you want to find out what is the object now, so you would call 1 or more of the accessors to find out what is the state of the object. You print those so that you know. And then you also print, and like I say, that's the most important step, then you also print the expected values. Now, there's some students who really dislike turning on their brain to print the expected values. And so they know there is a nifty shortcut. And that shortcut is to just leave this blank and then to run the program and then to look, oh, here was a 3. And here was a 4. Well then. So, look at that, isn't it great? Now it passes all the tests. Right? So clearly this is not effective. It'll give you momentary happiness, but when the grader runs our suite of tests, it's going to fail. So don't do that. And the temptation is there, particularly when the values are more complex, and you've got to resist that. Now you've noticed undoubtedly that good old NetBrat uses this exact same format. Let me try to find a NetBrat run here. Okay, no, I don't want to do this one. Let me do the bug. Okay. Oh, it has a different constructor. So now when I run it, then the actual printer is 1, and the expected 0 is highlighted in red so that you and the grader can see it. So what NetBRAD does, it simply analyzes the output. It looks at pairs of lines. So it looks at a line that has some value, and then it looks at the next line that's supposed to say expected. And if the values match, then it just leaves them in black. If there is a mismatch, then it puts it in red to call that out. There was a time when I put the matching ones in green, but green made people too happy. So black kind of leaves it neutral and says, you know, have a look at this, but nothing bad seems to have happened. So the red means something bad has definitely happened. Now in this particular case, because I'm only looking at the draft, that was maybe not fair. So let me look at the final one here. Oh, that doesn't look good at all, right? So at this point here, one wants to look at what does the tester actually do. How do we know what the tester does? Because NetBRAD tells us what it does. So here's the tester, and then you could run the tester at home and see what that does. So, but notice, by the way that I've formatted this thing here is so that you can take this and copy and paste it in here if you wanted to. And those line numbers, they're just comments. I put up the line numbers so that if there's an error message that you can trace it back to the line numbers, but they're just ignored here. And so yes, it's perfectly valid if you wanted to do this, and now you see that there's some issue here that you'd need to fix. So by all means, go ahead and take those testers back home and try them out. And you always notice me that when I want to do any kind of coding, I don't do any coding in NetBRAD. It's a tempting thing to do, to go into here and make some quick fixes in here, which I just did, right? So it's not true that I didn't do this. I just did this. And then I don't have them forever. As soon as my web connection goes, it's gone. So I should really go back here. Every time that I make a change, I want to capture it back in BlueJ. NetBRAD is just a testing tool. In an ideal world, there just would be a button up here. Like here would be a great place where it says NetBRAD. We do not live in this ideal world. We may in one day, if everyone else likes the stuff. All right. Now, by the way, that 2 parentheses. Yeah, so now I'm locally at the situation where things go wrong. And then I can start fixing it, and when everything is fine, I can then again go to NetBRAD. So there's no sense in going to NetBRAD all the time. Just get down what you have and work in BlueJ. There's been a bit of discussion, by the way, on whether you should work in BlueJ or whether you should be working in Eclipse or in whatever. So 99% of you can completely ignore this discussion and simply go on working in BlueJ. BlueJ works just fine for most of the semester. It has some nice properties. For example, watch this. That when I want to have some code here, why is it? That was not such a nice property. So if I type the name of a variable and then hit, you don't see that. If I hit Control Space, notice that then it gives me all of the various methods that I can call on that variable. And then you can just say, okay, I want this one here. And that's a great time saver, particularly in an exam. Right? The less typing you have to do in an exam, the better it is. So it's a good idea if you try this out at home. So the magic keystroke here is, let me just write this down, is Control plus space. So you type the first few letters of something, type Control space, and more often than not, it'll offer you this little menu of completion. It's well worth knowing. There used to be a time when BlueJ didn't have Control space, and I kept bugging the fellow who wrote it and said, you've got to put it in. And he said, well, I can't put it in because most instructors out there think that then the students will no longer memorize the names of the methods. That's crazy. No one remembers the names of the methods. Everyone remembers the first 3 characters of the names of the methods. Hits Control space, and then can recall them by seeing them spelled out. So there's no great glory, in my view, to memorize the names of a bunch of methods. You need to be able to recognize them, of course, when they're offered to you. And so they were finally convinced, and now it's in there. So some people said, why not just use Notepad? Why not just take a carrot and gouge out your eyes with it? I mean, both of them, are things that one could potentially do. So don't use Notepad for anything. And there will be ample times, for those of you who persist in doing it, when you will rue the day that you have heard of Notepad. Notepad does so many things poorly that it is not worth ever dealing with it. If you want to use a text editor for editing like configuration files or something, use Emacs. The lab will at some point introduce you to Emacs, and it is the one true text editor. And so
I've heard Vim is better.
there are people who believe that Vim is better, but there are also people who take those carrots and gouge out their eyes with them. Vim is not better. It's
You make $150,000 you're working for Alpha.
yeah.
Yeah.
That does not mean that they're right. So the reason that for a computer scientist that it's worth investing in an editor that has a broad capability is that it takes some time to learn any tool, and Emacs in particular is a tool that takes several years to master, but it really pays off later for more advanced things. When there's a new programming language coming out, for some reason, within months, someone has done an Emacs mode for it. That's very, very good, usually. That's actually almost as good as the IDEs and sometimes even better. So I'm right now working with a language called Scala, and Emacs is still a little bit better than most of the IDEs. It's faster, it's a little bit more convenient. It takes some time to set it up, though. It's really fussy to set it up, and I'm glad that I invested over the last 20 years enough that that setup for me wasn't a big hurdle, because it's made me more productive in this. Vim does not even begin to have the capabilities that one would need to build such a mode, and so it doesn't really have it. So if you do the same thing all the time, like a release engineer might, Vim would be great. Hopefully, most of you will not do the same thing most of the time in your career. It's not as exciting as doing lots of different things. And for that, you want to have a flexible system. That's why I recommend Emacs. I realize that there are other people, perfectly reasonable people who make lots of money, who have other opinions. So at some point, you need to decide for yourself. Try them both out. Look at the pros and cons. And eventually, you will be using Emacs. All right, it's a religious war, obviously. It really is. And so they're perfectly, I'm completely overstating that. There's perfectly good arguments either way. All right, so here I have another slide that highlights, just to really beat it down, everyone, the most important thing is that you print out what it is that you expect when you write those testers. So we will do this all the time. There's two kinds of format that you can do. You can just print a number and then print expected. Sometimes that's a little bit unfriendly because how do you know what it is that these numbers mean? And so in that case, you can print a label first. So for example, over here, I could print position colon. Let's run the tester. Okay, file saved. Compile. Okay. Now you notice that it has this position colon here, and when NetBrat runs something like that, NetBrat knows about this format, and it's going to ignore everything to the left of the colon. It's only going to compare this thing with that thing. And so that way, when you have a whole bunch of numbers, you can label them all, and that's a little bit more pleasant. So I suggest you do that. All right. So here we do have a tester for trim. Oh, I guess that was from the previous thing, that you should look up in the API notes what trim does. So go ahead and do that for this one as well. Go to the API of the string class, read through what the trim method does. So when we're in the API here, string, here's trim. And then let's answer this clicker question. Oh, that one. Okay. Where's my question? Oh, pff. Ever. Come on. Come on, Piazza. Okay, here we go. Okay. Interesting. All right. All I can say is the majority answer is not what I would have done. Not just that, it's wrong. Oh, great. Is it wrong? No, never mind. It's just not the best. All right, so let's go through these options here. The first one is wrong. Is it wrong? What's wrong about the first one? I'm not even calling trim, right? I managed to fool a few people, though. So it's not even calling trim, so it can't be right. So those of you who check this, have a good look at this. So over here, I am calling trim, and over here I am, and over here I am. So yeah, that was definitely wrong. Now over here, I'm calling trim, and then what I'm expecting hello without the spaces, there's actually still one space here, but then I've always put one space after the colon, so I guess that must be the space that belongs to expected. And then there's no space back here. So that's a candidate. Over here, this one we're having spaces around here, and then we're again having spaces around here. Well, trim would remove those spaces, presumably. And so that wouldn't even be testing the right thing. But if you think about it, it's going to be awfully hard to tell which of them is the right thing. So let me actually do this here really quickly. So I'm just going to make a trim tester here. Get rid of all of this stuff. This is annoying. And copy both of these in here. And now when you run it, so it's not all that easy to see what's actually happening, right? Because these white spaces are hard to see. Now the fourth test case, the one that a lot of people didn't really like, let me run it, and then we'll understand what it does. So you notice those bars around hello, that's what was actually printed. And the expected one also has those bars, so we expected to get those bars. So let's see what the code here does. So we're only concerned about this code here. So we're printing the vertical bar. We're then printing the trimmed version of hello. So far we have printed this bar, this hello. Then we're printing another bar, that's here, and a new line. That's the other bar. The new line gets us to over here. Then we're printing the word expected hello, so that's this whole thing. And so by surrounding both the actual and the expected with those bars, we can see any spaces very clearly. So if over here I had forgotten to call trim, or over here I had misunderstood it, maybe that would be a better way of doing it. If over here I had misunderstood what trim does and thought it only trims, say, the one to the left, then let's run the test case again. Then here we can see, this is what was actually happening, this is what I expected, and now you can see the mismatch. So when you do any output where spaces play any role at all, this is a nifty trick to do. Just surround the things with the vertical bars or with some other kind of mark. But vertical bars work pretty nice. And then that way you get an exact feeling for what's going on. All right. Last section, object references. So the idea is that you always want to have the right image of how objects are stored. We talked about this before, but it's worth doing it several times. So when I have a variable, and that variable holds an object, it does not actually hold the object. So there's not a rectangle sitting here. It's the wrong visual. What actually is happening is that box contains the location of the object, and that's the rectangle. Now remember, a rectangle is just something with 4 numbers. It's not a real rectangle. So here are my 4 numbers. That's what you have. Now when you make a second variable box2, then, and you say box2 equals box, like we're saying here, then that simply makes now a second variable that also points to the same rectangle. And now I'm going to call translate on box2. So let's blow these things up, and let's say over here I had x was 0 and y was 0. Now I call translate, that changes x to 15 and it changes y to 25, because translate moves the x and the y position by that amount. And now box 2, when I look it up, I can see the change. Notice that if I ask box where it is also changed, because box and box 2 are really the same thing. They're just 2 times the reference to the same rectangle. And that's okay. So whenever you apply a mutator on an object variable, and you happen to have other object variables that point to the same thing, then all of those observe the change. And so we have the same picture here. But numbers are different. So in Java, you have this distinction between objects and numbers. Numbers are immediately stored in their variables. So over here, we have lucky number equals 13. In here, the number 13 is actually stored in this little space. And so if you say lucky number 2 equals 13, or equals lucky number, then the 13 is copied into lucky number 2. Now, if you were to set lucky number 2 to 12, which I did here, that does not change lucky number at all. So mutating a number doesn't change the other numbers that were copied from it. Okay, so we've gone through this here, and I don't have to say it again. All right, so last clicker question of the day, and then I'll let you go. So the same kind of thing. I have a string, I have another string, I copy them, I call a method on the second one, and now what happens? So draw a little picture and see what happens. So for those of you who are done, what happens when so I've shown you what happens when you execute this line here. String greeting equals hello. That means greeting points to the object that has the hello inside. What happens when you do this line? Greeting 2 equals greeting. Then it links this one to short point to the same thing. What happens when you call greeting 2 dot uppercase? Ah, thank you. Yes, so that was wrong. So this stays hello. So where's the new string, the uppercase one? Yeah, it is actually right up here. Little known fact. There it is. And no one's ever saved it in a variable. So how can one ever find it? Yeah, right now the way the program is written, one can't ever find it. There's an object and no one can ever find it. It's so sad. What happens to the object? Yeah. Eventually, if the program runs for long enough and runs out of memory, this object gets what's called garbage collected. That's even sadder. An object that no one remembers gets just thrown in the waste bin and dies in a sad death, unnoticed by anyone. So this object got created, and no one did a thing with it, and that's okay, and it just sits there. So back to our quiz, what was the right answer? Well, it was this one here because they refer to the same thing which was never changed. Let's see how you guys were doing. And that was the majority answer, but I managed to fool almost a third. Who thought that? That third of you. Be sure to understand this stuff. It's actually important. Thank you.